We're going to be solving Cambridge IGCSE Chemistry Paper 43 extended October-November 2025 Paper 43. So let's get going. Atoms and ions are made up of particles called electrons, neutrons, and protons. Complete the table. So electron has a charge of -1, neutron has a charge of 0, proton has a charge of +1. That's, I guess, elementary school science. Relative masses. Electron has 1 upon 1840, neutron has a relative mass of 1, and proton also has a relative mass of 1. Table 1.2 shows information about some atoms or ions. Complete table 1.2. Okay, so we have to tell the number of electrons in a calcium ion. So the number of electrons are going to be 2 less than the number of protons, because the 2 plus charge means that you've lost 2 electrons, right? So initially you're 20 and you've lost 2, so you're going to have 18. Over here for a fluorine atom, we have 9 electrons, 9 protons, and for number of neutrons, we're going to do mass number, which is 19 minus 9 equals to 10. So we are going to have 10 neutrons, right? And over here they're telling that the number of electrons are 10, number of neutrons are 9, and number of protons are 8. The proton number is the identity of an atom. 8 protons tells that we have an oxygen atom, right? And since the proton and electron number is not balanced, this means we have a 2 negative. Why? Because electrons are 2 more than the protons. And lastly, we're going to have a proton number of 8 and a mass number of 8 plus 9, which is going to be 17, right? So there's going to be a 17 here. We have to add this and this to get the mass number. The relative atomic mass AR of an element is the average mass of its isotope compared to one atom of the isotope of X. Identify isotope X. We compare the mass of every atom to the mass of a carbon-12 atom, right? Not carbon-13, not carbon-14, carbon-12. A sample of magnesium consists of 2 isotopes with mass number 24 and 26. So one isotope has a mass of 24, the other one has a mass of 26. By the way, if you guys don't understand anything in chemistry, like I'm saying anything in chemistry, either it be A levels, either it be O levels, feel free to message any queries you have on this WhatsApp number 033 77 292 346. That's the number you message and your query is going to be solved, right? Don't worry about anything in chemistry. May it be A2, A1, anything that you feel stressed about, right? In chemistry, you can message and your worries are going to be gone. So 033 77 292 346, right? If you need any online class, if you need anything, you don't understand ATP, you don't understand graphs in chemistry, you don't understand a certain concept, you can message on this number. Okay. A sample of magnesium consists of 2 isotopes, this and this. Calculate the percentage abundance of the isotope of magnesium with the mass number of 24. So we have to calculate the percentage abundance, and 24.3 is the AR. Okay, so you got to understand one thing, 24 and 26, right? In between of them we have 25, right? This method might be a little difficult for you guys, so let's go with the formula, the traditional formula. 24 mass of the first multiplied by the percentage abundance of the first, which we are considering to be X, okay? So it's going to be 24X. And what do we do next? We have 24X over here, and plus 26, which is the mass of the second isotope, multiplied by 100 minus X, which is going to be the percentage abundance, upon 100 is going to be the sum of abundances, equals to the relative atomic mass, which is 24.3, right? 24X plus 2600 minus 26X upon 100 equals to 24.3, right? And then what do you do? Minus 2x plus 2600 equals to 2430, right? 2600 minus 2430 equals to 2x. 2600 minus 2430, 2600 minus 2430, 170. 170 equals to 2x. 170 upon 2 equals 2x. 85%. So 85% by mass is the percentage abundance. You don't have to add a percentage sign over here, is the one for 24, because for x we supposed x as the percentage abundance of the 24 isotope, right? Next we have a table 2.1 which shows the melting points, boiling points and electrical conductivities of 7 substances A, B, C, D, E, F, G. Identify which substance A, B, C, D, E, F, G is a gas at 25 degrees Celsius. So first we have to identify which is going to be a gas at 25. Firstly, if we talk about substance A, you can see for substance A, the melting point of substance A is above 25. That means that on 25 degrees Celsius, it's going to be a solid because it's going to melt at 1600 degrees Celsius. If it's going to melt at 1600 degrees Celsius at 25, it's going to be a solid, right? So this is going to be a solid and this is going to be a gas at 25. How do I know this? Because look at the boiling point. The boiling point is below the room temperature. That means at negative 183 it will turn into a gas, and when at negative 183 it's a gas, then definitely at room temperature 25 it's also going to be a gas, because as temperature increases it cannot turn back into a solid. It has to remain as a gas. This is going to be solid. This one here is going to be liquid at room temperature. I'm writing at room temperature. This one here is going to be a liquid. Why a liquid? Because at negative 7 it's going to turn into a liquid, and then at 25 it's going to remain a liquid because it's going to turn a gas at 58. So before 58 it has to remain a liquid. It's going to be a solid here and a solid here. Okay, at 25 we have written down the states. Now we have to figure out which is a gas. So there's only one gas, which is B, right? Next, a solid consisting of simple molecules at 25. So firstly we need to figure out a solid. So let's highlight all the solids we have. Solid, 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 solid. Now we have to consider simple molecules. Simple molecule means that it should have electrical conductivity in solid should be poor, electrical conductivity in molten should also be poor. So poor, poor, and then poor, good, this cannot be possible. Okay, then poor, poor, this is possible, and good, good, not possible, right? So we are looking over here poor, poor and poor, poor, but over here we need to realize, since we're dealing with simple molecules, so we should have low melting and boiling point, right? So over here the melting and boiling point for option A is very high, so we cannot consider option A, right? We have to consider option number F. Why do we have to consider option F? Poor, poor is fine for option A, but high melting and boiling point is not possible for simple. For simple it should be low, so we're going to consider option F over here. A metal which is a liquid at 25. So for metal, you know, electrical conductivity is good in solid as well, in molten as well. Why? Because you know that metals, they conduct by the movement of delocalized electrons, and since they conduct by the movement of delocalized electrons, their electrical conductivity should be good in both solid and liquid. So it should be good, good. So we're gonna highlight the metals that we have over here. It should be good, good. It should be good and good, right? These are all good, good, right? So over here we need to find out this one is a metal and this one is a metal. Option number D is a metal and option number G is a metal. Now we need to find out which is a liquid at room temperature. So this one is going to be a liquid, D, because you know we wrote it's going to be a liquid. Why? Because at negative 39 it's going to melt and boil at 375, so in between it's going to be a liquid. So option number D. And by the way, which metal are we talking about? A mercury. Mercury is the only metal that is liquid at room temperature. Identify which substances A, B, C, D has a giant covalent structure. Giant covalent structure, obviously we figured out option number A has a giant covalent structure because giant should have poor and poor, and secondly it should have a high melting boiling point. Why it should have poor? Because there are no delocalized electrons in giant structures except for graphite. Graphite is an exception. So we are gonna tell substance A, reason 1, high melting boiling point, because giant have high melting and boiling point. You're gonna write the full form. And reason 2 is poor electrical conductivity, because we know that diamond and silica, they don't conduct in liquids as well as solids. Poor electrical conductivity in solid and molten. Okay, identify which substance is an ionic compound. Use the information table 2.1 to give reason for your choice. Okay, so we have to identify which is an ionic compound. The first things first, ionic compound is going to be poor in solid and good in liquid, right? So it should be poor in solid, and good in liquid. So poor, good, this combination, poor, good, and do we have any other poor, good combination? So poor and good we need, because in solid the ions are not free to move, in liquid ions are free to move. So poor, good, only one combination. So it's going to be option number C, right? We're going to tell them option number C. And why is it C? It's C because a reason, poor melting point in solid and good, not melting point, poor electrical conductivity, sorry, not melting point. We have to deal with electrical conductivity over here. So it's going to be poor electrical conductivity. EC I'm writing for the time being. You write the full form: poor electrical conductivity in solid and good in liquid. That means, or you can say when molten, that means the ions are delocalized over here. Okay, this question is about aluminum and other metallic elements. Aluminum is extracted from purified bauxite by electrolysis. Figure 3.1 shows the diagram of the electrolytic cell used. So we have a negative electrode, which is the anode, not the anode, the cathode, sorry. The negative electrode is the cathode over here, and then we have a positive electrodes, which is the anode. You know, at the cathode we're going to form aluminum, at the anode we're going to form oxygen gas that's going to then react with carbon to form carbon dioxide. Okay, state the name of the aluminum compound present in bauxite. Aluminum oxide, so it's aluminum oxide is present in bauxite. It's an ore of Al2O3. Right, name the substance that purified bauxite is dissolved in before electrolysis is carried out. Cryolite. To reduce the melting points and the operating temperatures. Name the substance that is used for the positive electrodes. The cathode we use graphite, or you can say we use carbon for the cathodes, for the anodes. Why do we use graphite or carbon? This entire is graphite or carbon so that the oxygen formed reacts with the carbon to form carbon dioxide, right? Write the ionic half equation for the production of aluminum at the negative electrode. So ionic half equation for aluminum is going to be, we have aluminum 3 plus ions. They're going to gain 3 electrons, and then we are going to form aluminum liquid, right? Ionic half equation, yeah, we're done with the ionic half equation. 3 plus gaining 3 electrons, right? Aluminum is above zinc in the reactivity series. When a piece of aluminum foil is added to aqueous zinc sulfate, a reaction is not immediately observed even though the aluminum is above zinc in the reactivity series. Explain why the reaction is not immediately observed. Because whenever you're going to have aluminum, always remember you're going to have a layer of aluminum oxide on it, which is Al2O3, and aluminum oxide is a non-reactive layer. So we're going to tell the examiner that our aluminum has a layer of Al2O3, which is our aluminum oxide on it, which is unreactive, right? It does not react. After a few minutes, a displacement reaction occurs between aluminum and aqueous zinc ions. Complete the ionic half equation for this reaction. Okay, so what's basically happening is that you got to realize one thing. Aluminum is gaining 3 electrons, right? 3 electrons, and zinc is losing 2. So to balance 2 electrons and 3 electrons, you're going to put 3 over here, a 3 over here, a 2 here, and a 2 here. Because 3 zincs are going to lose 2 electrons, so you have a total of 6 electrons. Then 2 aluminums can gain these 6 electrons because 1 aluminum needs 3 electrons. So 2 aluminums are going to gain 6 electrons. That's how you balance out such equations. You make the number of electrons equal. The electrons gained and lost should be equal. State the oxidation number of zinc in Zn2 plus. It's going to be positive 2 in Zn0. Define the term reduction in terms of oxidation number. Reduction means a decrease in oxidation number. So if your oxidation number decreases, you're reducing. Aluminum reacts with iron 3 oxide, aluminum iron 3 oxide. Aluminum is going to displace it definitely because it's more reactive. State the meaning of the symbol delta H. Delta H means enthalpy change. State what can be reduced about the reaction from the negative sign. It is exothermic. If it's a positive, it's an endothermic reaction. No worries. Gallium has many similarities to aluminum. Gallium oxide has an amphoteric oxide. State what is meant by the term amphoteric. Amphoteric means that the oxide reacts with both acids and bases to produce salt and water. The reaction of gallium 3 oxide Ga2O3 with aqueous sodium hydroxide forms a salt which contains a negative ion. This, okay, so they're saying that this gallium oxide, okay, is basically reacting with sodium hydroxide. It's reacting because, you know, it's an amphoteric oxide. It's going to react with a base as well, or an alkali, form a salt which contains GaO2 negative ion. The only other product is water. Write the symbol equation for this reaction. Okay, so simple that we have Ga2O and then we have NaOH, and they're telling that the negative ion contains GaO2 negative. To balance the one negative, we are going to have a sodium over here. This one negative goes away. To write a simple equation and then plus H2O. Now the only other product is water. Now you got to realize one thing, that this equation, is it balanced or not? No, we need 2 over here, right? We got to balance out the galliums. Ga2O3, right? O3. So now we got to balance the waters as well. So we're going to put A2 here. Oxygen's balanced. We put A2 here to balance out the sodiums. We have 3, 4, 5 oxygens. We have 4. We have 3. Wait. We have 2 here. Okay, let's see. Are we balanced? Okay, so we have 2 galliums, we have 2 galliums, we have 2 sodiums, we have 2 sodiums. Gallium and sodium is balanced. Now, how many oxygens do we have? We have 3, 4, 5 oxygens on this side, and 4 plus 1, 5 oxygens on this side, and then we have 2 hydrogens on this side, and 2 hydrogens on this side. So we're done. Reduce the formula of gallium 3 bromide, GaBr3. What's the difficult? 3 means it has a positive 3 charge, so it's going to be Ga3 positive, Br1 negative, crisscross. Gotta require 3 bromides to balance out 3 positive, gallium 3 sulfate, Ga2SO4 3. Why? Because gallium has a charge of 3 plus, right? And sulfate has a charge of 2 negative, right? This 2 negative comes down here, this 3 positive comes down here, it becomes Ga2SO4 3. Okay. This question is about chlorine and the compounds of chlorine. So, okay, no worries. Chlorine and the compounds of chlorine. Gaseous chlorine reacts with gaseous phosphorus 3 chloride to form gaseous phosphorus 5 chloride. The reaction is reversible. So if chlorine, you have PCl3, you're making PCl5, which when 3 gases in a closed container are put, they reach equilibrium. Describe a reversible reaction at the equilibrium in terms of rate of the forward reaction, the rate of the reverse reaction. You should know that whenever you have equilibrium, rate of the forward reaction equals to the rate of the reverse reaction, so they are the same. The concentration of the reactants in the products, it remains unchanged, right, or constant. You can tell the examiner that it does not change. So these are the 2 conditions of the equilibrium. Complete table 4.1 using only the words increases, decreases, or no change. Change to the condition. The pressure is decreased. Whenever you decrease pressure, you should know that there are 2 things: the rate of the reaction and the equilibrium, right? The rate of the reaction does not depend on equilibrium. Equilibrium does not depend on the rate of the reaction. So whenever you decrease the pressure, the rate is definitely gonna decrease. So the rate is definitely gonna decrease. But effect on the concentration of PCl5, we would have to figure out. you know there's 2 moles of gases on this side, 1 mole of this, 1 mole of this, and 1 mole of this. So when we decrease pressure, you know, whenever we decrease pressure, the equilibrium move towards the side that has more moles. So it's going to move backwards, and when it's going to move backwards, PCl5 is going to decrease, right? So the concentration of PCl5 is also going to decrease. Okay, a catalyst is added. A catalyst always increases the rate of the forward and the backward reaction, and it does not affect the equilibrium. Catalyst can never affect an equilibrium, right? So that's the thing. When the temperature of the equilibrium mixture is increased, the equilibrium concentration of PCl5 decreases. Okay, so what's happening is that you have Cl2 and then you have PCl3, and that's forming PCl5. And when you increase the temperature, right, temperature increases, the reaction is going to move backwards, right? Because when you increase the temperature, the reaction moves backwards, right? Why does it move backwards? It tries to decrease the temperature. That means the backward reaction is endo, right? And if the backward reaction is endo, that means the forward reaction is exothermic. I'm going to explain it to you again. When the temperature of the equilibrium is increased, the equilibrium concentration of PCl5 decreases. So when you increase temperature, the equilibrium basically tries to decrease it, and to decrease it, it's going to move backward. If it's moving backward to decrease it, that means it's doing endo, right? If backward is endo, then forward is going to be exothermic. So we're going to tell that forward reaction is exothermic. Ethene C2H4 reacts with chlorine. Ethene reacts with chlorine to form 1,2-dichloroethane. Okay, we have a addition reaction. The equation for the reaction can be represented. The table 4.2 shows some bond energies. Use the following steps. Calculate the total energy needed to break the bonds in C2H4 and Cl2. Okay, so in order to break all the bonds, firstly I would have to break 4 CH bonds. So I would have to break 4 CH bonds, plus I would have to break a C double bond C, plus I would have to break 1 Cl bond, right? So for 4 CH bonds, the energy for one bond is 410. So 1 times 410 plus 1 C double bond C is 610 plus 610, and plus 1 Cl bond is 340. So if I do the maths on my calculator, 4 times 410 plus 610 plus 340, that is 2590, right? So it's got to be 2590. That's the total energy that I'm going to give it to break all the bonds. What are the bonds? This. So 2590, right? 2590 is the total energy given to break the bonds. Calculate the total energy released when the bonds are formed. Okay, so the total energy released is, I have 1 CCl bond, 2 CCl bonds. So 2 times CCl bonds plus 1, 2, 3, 4. 4 times CH bonds plus 1 CC bond plus 1 CC bond, right? So 2 times CCl bonds, which is 340, plus 4 times CH bonds, where's plus 4 times 4 tenths, plus C bonded to C, which is 350, right? What do I get? 2 times 340 plus 4 times 410 plus 350. 2670. Yeah, that's the amount of energy released. 2670. Now, what do I have to calculate? I would have to calculate the bond energy. For bond energy, remember, what do? You calculate, you minus total energy that's basically given from the total energy that's released. So it's going to be 2590 minus 2670, right? 2590 minus 2670, negative 80 kilojoules, right? Negative 80 kilojoules. Chlorine reacts with nitrogen to form nitrogen trichloride. Okay, no problems. Complete the dot and cross diagram of a molecule of NCl3. Show the outer shell electrons only. Chlorine is in group 7. Group 7 means it's going to make one bond only, and nitrogen is in group 5. Group 5 means that it needs a total of 8 electrons. It needs 8 electrons, that means it needs 3 more electrons. If it needs 3 more electrons, it's going to make 3 bonds, right? So fill all the remaining electrons for chlorine. Two for nitrogen. Done. Okay, when solid magnesium carbonate is added to dilute hydrochloric acid, a chemical reaction occurs. The equation is shown. Okay, we're adding which two observations shows that magnesium carbonate is added to dilute. Which two observations when solid magnesium? Give two observations when solid magnesium carbonate is added. Firstly, we're adding magnesium carbonate. We're going to form a gas. So we're going to see bubbles or effervescence, right? We're going to see it. And the second thing that we're going to see is solid is going to disappear, right? Because when solid magnesium carbonate, solid disappears, right? Solid disappears, right? The solid is going to disappear, simple. Calculate the volume in cm cube of carbon dioxide that is produced at room temperature. Okay, 150 cm cube of this HCl reacts with excess MgCO3. The volume of 1 mole of any gas is this at RTP. Use the following steps. Calculate the number of moles of HCl in this. Okay, so we simply know that our moles equals to our concentration times our volume, right? So moles equals to 50 divided by 1000 multiplied by 0.100. So 50 upon 1000 times 0.100, that gives me 5 into 10 raised to power negative 3 moles. So 5 into 10 raised to power negative 3 moles. Reduce the number of moles of carbon dioxide. So that's the number of moles of HCl. You know that I have the moles of HCl. Now I need to figure out the moles of carbon dioxide. Look at the ratio, 2:1. So HCl ratio CO2 is 2:1. So if HCl is 5 into 10 raised to power negative 3, CO2 is going to be divided by 2. So it's going to be x equals to 5 into 10 raised to power negative 3 divided by 2. X equals to 2.5 into 10 raised to power negative 3. Calculate the volume of carbon dioxide. We have the moles. If we multiply the moles with 24,000, we get the volume in cm cube. So moles equals to 2.5 into 10 raised to power negative 3 multiplied by 24,000 multiplied by 24,060 cm cube. This question is about metallic compounds. Insoluble metal salts such as lead sulfate are made by precipitation. Okay, so insoluble sulfates are made by precipitation. We know for precipitation we use two soluble salts to make an insoluble salt. Okay, when aqueous lead ions react with aqueous sulfate ions, a precipitate of lead sulfate forms. A sample of pure lead sulfate can be obtained from the precipitate. Form ionic equation for the precipitation reaction. So you have lead ions, which are lead 2 plus ions. They should be aqueous. I told you we take two soluble salt. Then you should have sulfate ions. They should also be aqueous. We take two soluble salts, and then you're going to form lead sulfate, PbSO4, which is going to be a solid because that's a precipitate being formed. State the name of the aqueous solution containing lead 2 ions. So we can take lead 2 nitrate, right? State the name of the aqueous solution containing the sulfate ions. We can take sulfuric acid. The lead sulfate precipitate separated by filtration. The impure lead sulfate solution remains. That's called the residue. State the general name given to an insoluble substance that remains on the filter paper. Residue. The below substance is the filter. Describe how lead sulfate is purified after filtration. You wash the PPT and then you dry it, right? Between sheets of filter paper. You can write between sheets of filter paper. Okay, so now let's continue. Copper is a transition element. A list of properties of copper is shown. Okay, done. Give two properties from the list that show copper has is similar to group 1 metals of the periodic table. Okay, so it is good electrical conductivity. That's also a property of group 1, so that's going to be the one. It has variable oxidation states. Group 1 don't has it. It forms soluble salts. Okay, we can think about it. It forms a basic oxides. Group 1 also form basic oxide. It acts as a catalyst. Group 1 don't. It forms soluble salts and it forms basic oxides. So any two. Give two properties from the list to show how copper is similar. So we're gonna say it has good electrical conductivity, and the second is gonna be it forms soluble salts group, because group 1 salts are all soluble. Give two properties from the list to show that copper is different from the metals in group 1. All the rest, it is variable oxidation states. Group 1 only has fixed, which is +1. It has variable oxidation states. It acts as a catalyst. Group 1 cannot. Okay, this question is about organic compounds. Organic compound Q is the following composition. Calculate the empirical formula. Carbon ratio, hydrogen ratio, oxygen 50.00. Okay. Hydrogen is 5.56, oxygen is 44.44, divided by 12, divided by 1, divided by 16. Let's see what do we get. 50 divided by 12, we get 4.167, 5.56, and 44.44 divided by 16, we get 2.76. So 2.76 is the smallest, so we're going to divide all by 2.76. 4.167 divided by 2.76, we get 1.5 here. 5.56 divided by 2.76, we get 2 here, and we're going to get 1 here. Okay, so we get C as 1.5, we get H as 2, and we get O as 1. Since you know that this is not possible, we cannot write 1.5 in the empirical formula. We're going to multiply all three of them with a number. That's 2. So 2 1.5 times 3 to 2 times 4 and 2 1 times 2. So over here we get C3H4O2. C3H4O2. Organic compound R has empirical formula CHO and a relative molecular mass of this. Determine the molecular formula of compound R. Okay, so what do? First we calculate the empirical formula mass, right? The empirical formula mass for CHO is going to be carbon is 12, hydrogen is 1, oxygen is 16. Okay, so 12 plus 1 plus 16, that gives me 29, right? Then we take the molecular mass, which is 116, divided by the empirical formula mass, which is 29, and see what we get. We get 4. Then we multiply our empirical formula, which is CHO, with the number of value n we get, which is 4, which is going to be C4H4O4. C4H4O4. Carboxylic acids react with alcohols to form esters. Name the other product that is formed when a carboxylic acid reacts with an alcohol. Always remember water also forms in esterification. Name the type of catalyst. We use H2SO4. The type of catalyst, they're not asking about the specific catalyst, so the type of catalyst is a acid catalyst, right? Ester S has this structural formula. Name the carboxylic acid in the ester. We're going to break it from the center, right? The carbon that has no hydrogens with it, is basically the acid part, and the carbon that has a hydrogen with it is the alcohol part. So the acid part has 1, 2, 3 carbons, so that's definitely propanoic acid, and the alcohol part is 1, 2, 3, 4, so that is butanol. Okay, Figure 6.1 shows part of a polymer structure. That's the polymer structure. Name the type of polymerization. We're forming a continuous long chain polymer. That's addition polymerization. Definitely we have it in alkenes. So just why is it not possible to write the molecular formula for this polymer? Okay, it's not possible to write the molecular formula because it is a long chain. So thousands of repeat units long. So it has a lot of repeat units. That's the way. It is a long chain, thousands of repeat units long, difficult to count, and everything, whatever. State the number of monomer units that are needed to make the polymer structure shown in figure 6.1. Okay, so 1 repeat unit, 2 repeat unit, and 3 repeat units, right? 1, 2, and 3. Okay, state the number of monomer units needed to make, so I guess 3. Draw the displayed formula of the monomer used to make this polymer. Okay, so first we're going to draw a repeat unit. How does a repeat unit look like? Extend the bonds inwards like this. CH3 upwards, CH3 upwards, and then there's an H, and then there's an H. Okay, so now we draw the displayed formula for this fella, right? So it's a CHH, then it's a C double bond C, then it's again a CHH, HH. And that's butene, right? Done. Figure 6.2 shows part of the general structure of an amino acid. We know it. Complete figure 6.2 to show all the atoms and all the bonds of the two functional groups of the amino acid. One amine group, nitrogen, hydrogen, hydrogen. One carboxylic group, right? Carboxylic group, amine group. Okay, so over here on figure 6.3, draw a circle around one amide linkage. Amide linkage, yellow bhai. Yellow, that's an amide linkage. One amino acid connected to another by an amide linkage. State the name given to the natural polyamides made from amino acid proteins. Proteins are natural, right? Done and dusted.